Hello everyone. In this case, we're going to see the continuation of the series, and we're going to start checking for statics. Now, when you have a population, you can separate this population in different samples. You can have like different number of objects that are going to be in each sample, and this is going to check the values that we're going to obtain from these samples. For example, we calculate the mean, the variance, standard deviation, range. All of this is going to change depending of which sample you choose and which quantity of objects is going to be in each sample. Well, now we're going to define other terms that are going to help you that is called statistics. Now, and statistics is going to be called each set of values that we can quantify in a sample. For example, the mean, variance, expected value, all of this is going to be statistics that we can get. Now, given that in a population we can have multiple samples and multiple forms of measuring this part, we are going to obtain a probability distribution of the possible values of the statistics. Now, this is called a sampling distribution because we are taken out from the samples. What happened with this is that since we are changing values, I have a misunderstanding. Well, now there are two ways to get this sample distribution. We can, for example, have a physical experiment that, for example, we have a population of 100 people and we want to get samples like 10 people, 11 people, all that. It's an experimental part and we can measure this, but there is other way. There is a simulation experiment. There are a lot of software that can get you some simulation experiments from the data that you take in. And these simulation experiments are going to give you the necessary information, like for example, statistic of interest, population distribution, sample size, all of these things. They're going to give you an approximate way to get, so you can draw conclusion from this sample to the general population. Now, in a sample, as we have mentioned, you can separate it any number of objects that you want. So, what happens if you put like a small number of objects of a high number of objects? What's going to happen? Well, what happens is if you put more objects, like for example, we have 10, and then I measure it and compare it to a sample of size 20, and that I compare it to a size of a population of size 100 and all of that. What happens is that from every object that you put in your sample, the more objects that you have in your sample, the more the mean and all that, the statistics that we can measure are going to be much more related to the one of the population. Because you will have a more big sample, a more random sample, and it's going to be a more characteristic sample to the population. But for example, if you only randomly choose 10 objects, it could be a characteristic sample, but given all the uncertainties and variations that happen between each event, this is not going to be, going to be more not so close to the mean. Like it will be like a sample with a lot more of objects inside our population. So, well, this video was only for the definition of the statistics and how this can be used in the sample and this part. So, thank you and see you in the next one.